Good evening. So here is our assignment for the mathematical statistic SV21403 in real-world application of random variables bivariate distribution. So here is our team members. The first one is me, N.Atikah Alexander, BS2111096. Second is N.Atikah Syahirah binti Herman, BS211100209. Third is Rosemary John, BS211102229. Fourth is Muhammad Danish Hazimi bin Ramli, BS211100307. And the last one is Nur Syahirah binti Jul Edi, BS211100278. Here is the introduction for the bivariate distribution. Bivariate distribution refers to a statistical concept that provides probabilities for the occurrence of simultaneous outcomes involving two random variables. It enables the analysis and understanding of the joint behaviors of these variables, allowing for the examination of the correlation, dependencies, and interactions. By studying the bivariate distribution, we can gain insight into the combined probabilities of different outcomes, aiding in various fields such as economics, medicine, and social science, where the relationship between two variables is of interest. But our team is focusing more on medicine and public health.
Assalamualaikum, I am N.Atikah and I'm gonna continue as the next presenter. Bivariate distribution has numerous real-life applications in various fields such as finance and economics, environmental science, market research, social science, and quality control. But our group are focusing on medicine and public health, which is the relationship between BMI and systolic blood pressure. Bivariate distribution are employed in medical research to examine the relationship between two health-related variables such as age and blood pressure, BMI, blood pressure, and so on. By understanding the joint distribution, researchers can identify risk factors, study effectiveness of treatments, and make predictions about health outcomes. Alright, this is the example. Let's consider a hypothetical example where we have collected data on the BMI and systolic blood pressure of a sample individuals. Suppose we have the following data of 5 people from person 1 to person 5 with different BMI and SBP. To analyze the relationship between the BMI and blood pressure, we can calculate the correlation coefficient, which measures the strength and duration of the linear relationship between the two variables. To find the correlation coefficient, first we must find the mean for the both data, which is BMI and blood pressure. And after we got the mean, now we are going to find the standard deviation. After we got the value for the both data, then we substitute it into the correlation coefficient formula. Now we substitute the data into the formula, and for the BMI, the mean is 25.8 and the standard deviation is 1.58. And for the SBP, the mean is 123.6 and the standard deviation for the SBP is 5.01.
So by using the formula to find the correlation coefficient, we get the R is equal to negative 0.897. So the correlation coefficient range is between negative 1 and positive 1. In this case, the negative value indicates the negative correlation, suggesting that as BMI increase, systolic blood pressure tend to decrease. By analyzing the bivariate distribution and calculating the correlation coefficient, we can gain insight into the relationship between BMI and blood pressure. This information can be useful in assessing the risk factor for the cardiovascular disease and developing intervention to promote public health.
My name is Muhammad Danish Hazimi bin Ramli, and I'm going to present to you about the benefits of bivariate distributions. In decision making under uncertainty, personalized treatment plans, and also assessing cardiovascular health. So, in decision making under uncertainty, the bivariate distribution enables decision makers to assess the probability if different outcomes when faced with uncertainty. For example, in project management, considering the joint distribution of time and cost variables can provide a more accurate estimate of project completion time. This allows for better planning, resource allocation, and risk management. For personalized treatment plans, bivariate distributions provide a comprehensive understanding of the relationship between BMI and blood pressure, enabling healthcare providers to design personalized treatment plans. By considering the interplay between these variables, medical professionals can identify optimal interventions tailored to each patient's unique health profile, resulting in more effective and targeted care. And for assessing cardiovascular health, bivariate distributions play a crucial role in evaluating cardiovascular health. By analyzing the joint distribution of BMI and blood pressure, healthcare providers can assess the correlation between these factors and identify potential risk for cardiovascular diseases. This information helps in early detection, prevention, and management of conditions, leading to improved overall cardiovascular health for outcomes for patients.
So here is the question: what insight can be gained from studying the bivariate distribution of BMI and blood pressure?
Thank you for the question, and my answer is examining the bivariate distribution of BMI and blood pressure helps identify correlations between these variables. This information is crucial for recognizing potential health risks such as hypertension or metabolic disorders and enable healthcare professionals to tailor intervention, lifestyle modification, and monitoring protocols accordingly. I hope that answers your question.
For question 2, how might bivariate distribution be used to predict BMI and blood pressure related health outcomes?
Thank you for your question. So here is the answer for your question. By leveraging bivariate distribution models, we can develop predictive tools that estimate the likelihood of specific medical condition based on BMI and blood pressure. This supports proactive healthcare planning, risk assessment, and early intervention strategies, promoting better health outcomes and disease prevention. Thank you. I hope this answer might satisfy your question.
So for the last question, how can bivariate distribution of random variable be applied in medical use?
So here is the answer for your question. Bivariate distribution allows us to analyze the relationship between BMI and blood pressure, providing insight into how changes in one variable impact the other. This helps in understanding the connection between weight and cardiovascular health, aiding in medical diagnosis, treatment planning, and preventive care strategies.
So that's all for our presentation about real-world application of random variable bivariate distribution. Thank you for listening our presentation.